Welcome to Networking and Health Information Exchange, Basic Health Data Standards. This is Lecture A. In this lecture, we will examine the problems caused by the lack of a single terminology and why that limits our goal of semantic interoperability. A key requirement for semantic interoperability is the ability to understand what the other person is saying. Data elements are the building blocks for this communication, and we will discuss this topic in some detail. Terminology can be considered to be a subset of data elements. We will look at many of the more popular controlled vocabularies today and understand the source. We will describe the use, purpose, and interrelation among sets of controlled vocabularies in use today. The objectives for this lecture are to understand why it is necessary to use a common set of data elements with common names to be able to exchange and understand data from other places. Understand what is meant by semantic interoperability. Understand many of the sets of controlled vocabularies in use today, how they are used, and who requires their use. A fundamental problem has existed in storing and sharing health data electronically. That problem is the lack of a standard set of data elements unambiguously defined with a common set of attributes, particularly the name or terminology of the data element or item. Even within a single institution, data cannot be aggregated easily. The HIT community has been reluctant to address this problem for many reasons, including economic pressures not to change, indecisions about what is the solution, inability to agree on terms and processes, and the lack of a decision body with sufficient clout to make it happen. The problems are, we all speak a different language. One institution had a project to create an institution-wide registry for patients with diabetes. They were unable to do so because of the absence of a common vocabulary. The Joint Commission, which collects data from all hospitals, cannot do an analysis on an aggregated data set because of the absence of semantic interoperability. They analyze subsets of the data and merge the analyses. Understanding what the data says. When you say heart attack, and I say MI, are we talking about the same thing? What do you mean by angina? Is that what the patient has when she says, I have chest pain? Understanding what the data means. When you say elevated blood sugar, are you and I using the same metric? In a study in 2000, one researcher identified over 60 different definitions for unstable angina through a study of the literature. Understanding where the data is in the electronic record. Data frequently cannot be found in EHRs, although it does exist at some place in the record. Depending on the test, the same data element may be stored in different places in the record as a component of the different test. We don't define the degree of granularity at which we store the data. Understanding the context in which the data is collected. Was this lab test just after the patient had eaten? Most new projects start off with the definition of what is called a minimum data set. The same words are often reinvented every time a new minimum data set is defined. If we misinterpret what a word means, we may make a medical error that results in an aggravation of a patient's condition or even death. Semantic interoperability is the ability to share data whose meaning is unambiguously clear and precise, its context understood, and it can be used for any purpose. With true semantic interoperability, the receiver may be totally independent from the sender, or even unknown to the sender. The receiver does not need to have previous understanding with what will be exchanged and how. Additionally, we need to know how to package the data that is shared so that receiver understands the context of the data and its relationship to other data. There are many problems that prevent us from achieving semantic interoperability. Same words that have different meanings. Different words that have the same meaning. Words that are too general to convey a specific meaning. Localisms that lose meaning beyond that region. Failure to pay attention to factors other than name, such as units or how measured. Inconsistencies in the level at which things are described. Here are some examples that make these points. Do you say sex or gender? When you ask, do you smoke, what do you mean? Now, last month, last year, last 5 years, or ever? Do you record male, man, or boy? Humans recognize the distinction, but does a computer unless it has been taught? Heart attack versus chronic heart failure versus myocardial infarction. Moderately versus severe. Congested, restricted. Chest pain is a symptom that can have many causes. Consider local and cultural terms. What is bad blood? Is HBP the same as high blood pressure? Is the same as hypertension? Is the same as essential hypertension? Is the same as benign hypertension? Is that distinction important? What are synonyms and which are, in fact, different terms? What does fever mean to you? Or a high fever? What do you mean by weak? How evidenced? Do you measure height with the shoes removed? Do you remove coats and sweaters when you measure weight? What is the patient's position when you measure the blood pressure? What has the patient been doing prior to the measurement? Who made the measurement and how? What do we do with all the data that currently has been collected? Do we throw it away, or do we try to convert it to the new data elements? Semantic interoperability requires many different parameters to be addressed. For example, consider the term itself. How specific is the word that is used? How precise is the meaning? One person may say heart attack, which is a highly generic term covering a lot of specific problems. Someone else may say myocardial infarction. Another may say heart failure. Are these the same? Units must match or at least be known. Is the weight expressed in pounds or is the weight in kilograms? For compound data items, such as the results from a Pap smear, what is the structure of the result reporting? How can you find the pieces you want? Fundamentally, there is no standard vocabulary in use for healthcare today. Most legacy systems are unstructured, undefined, uncontrolled narrative, or free text. Many groups are dealing independently with some terminology and data elements. No group is dealing with all. Too many solutions are no solutions at all. Many terminologies exist, but all fail to meet all the requirements. Do we try to fix what is, or do we make a new approach? Most institutions today are not willing to commit to changing from a local terminology to a standard set of data elements because of the costs. And until a decision is made nationally, that will be sustained. Until we commit to a solution, we will use workarounds that do not solve the problem. Most workarounds cost money, cause a loss of information, and are never up to date. Those workarounds usually involve mapping from one terminology set to another. The confusion begins when we try to identify what we are talking about. Different coding systems are classified in one of these categories. Does it matter? These are the different words you will hear when talking about data elements. All of these words sort of mean the same thing, but are different. For the purposes of this lecture, we use the words interchangeably, with data element as the root word. A vocabulary is a set of words used to express a concept or thought. It means that some organization has placed some constraints and organization on the set of words and manage content. It is an organized list of words and phrases used to tag content. Examples include logical observation identifier names and codes, LOINC. A terminology is considered by most to be a synonym of vocabulary. It is a system of specialized terms and a symbolic representation of conceptual information. It is a finite, enumerated set of terms intended to convey information unambiguously. It is a body of terms assigned to or used for a particular type of thing. A terminology is essential for proper data storage and retrieval, and requires an internationally recognized nomenclature of diseases, pathology, clinical indicants, treatments, and surgical operations. A nomenclature refers to a system of names or terms used in a particular science or art. It is a consistent, systematic method of naming to denote classifications and avoid ambiguities. Names of anatomical structures or organs of the body are usually referred to as a nomenclature. An example is SNOMED. A classification is a grouping of objects into a class or classes according to some common relations or attributes. Examples are International Classification of Diseases, ICD-9 or ICD-10, and International Classification for Primary Care, ICPC. A taxonomy is a practice and science of classification. Taxonomies are typically arranged in a hierarchical structure and exhibit parent-child relationships. An ontology consists of basic categories of being and their relations. It deals with questions concerning what entities exist or can be said to exist, how such entities can be grouped, related within a hierarchy, and subdivided according to similarities and differences. An ontology is a formal representation of a set of concepts within a domain and the relationships between those concepts. A grouper groups together diagnoses and procedures that are similar resources used for billing purposes. An example is DRG. Basic features of terminology include a unique identifier, code that has these characteristics, numeric and without meaning, may include check digit. Moving toward use of ISO-based object identifier, called OIDs, paths in a tree structure. Assigning authority is assigned to organizations who in turn assign the identifiers. HL7 is an assigning authority at 2.16.840.1.113883 joint ISO itut.country.us.organization.hl7. Official name. An example is female. Terminology may have synonyms such as woman or girl for female. Codes have the value of being absolute, precise, and unambiguous. If codes are what we exchange, we cannot misinterpret. We can further relate the code with a set of attributes or characteristics, as a preferred name or a synonym. We can express the name and concept of the data element in any language. The code might include a check digit for detecting entry errors. The coding system needs to be universal. The movement for assigning codes in the future is toward using ISO object identifiers, OIDs. However, most vocabularies in use today already have a coding system. These coding systems are unique to the controlled vocabulary. In many cases, the codes attempt to carry information in their format and structure. For example, the code shows the body system involved, or the code shows linkages, or the code relates to the name, such as M equals male. It is useful to assign data elements to classes or categories. Most systems would use categories similar to these: demographics, signs and symptoms, anatomy, physical findings, diagnostic procedures, organisms, diagnoses, medications, allergies, therapeutic procedures, adverse events, and genomics. In some cases, a coding system will only include terms in some of these categories. If we depend on just one coding system, we have data items we cannot code. Of course, everything we record does not fit into these categories. Then what do we do? Let's take a look at a specific data element, gender, and see how complicated even a simple data element might be. How many values might the answer to this question have? What is administrative gender? What happens if we are talking about clinical gender? How do we distinguish gender if we are talking about X and Y chromosomes? What if we can't determine gender? Note the distinction in the two unknowns. Which does just unknown mean? Is this definition sufficient? An obvious answer to the gender question might be two, male and female. But what if we are talking about gender from a clinical perspective? Some terminologies have as many as 27 different values for this term. Several terminologies break gender into two terms. The first is administrative gender, and the second is clinical gender. How do we represent the values that may be assigned to gender? Classically, we have used letters, names, and numbers as possible values among the different users. There are over 400 different terminologies in use throughout the U.S. today. The more important and popular of these terminologies are listed on these two slides. How do we know which to use and for what purpose? Is it any wonder that we are having trouble sharing and understanding clinical data? Choices include International Classification of Disease, ICD, WHO. Current version in the U.S. today is ICD-10. Common Procedural Terminology, CPT, American Medical Association. Diagnostic and Statistical Manual of Mental Disorders, DSM-4, American Psychiatric Association. Diagnosis-Related Group, DRG. National Drug Codes, NDC, FDA. RX Norm, FDA. VA National Drug Formulary. Structured Product Labeling, FDA, HL7, and Logical Observation Identifiers, Names and Codes, LOINC, Regenstrief. The list continues. Medicine, SNOMED, CT, IHT, SDO, International Classification of Primary Care, ICPC, WONCA. Medical Dictionary for Regulatory Activities, MEDRA, ICH. Nursing Terminologies, MESH, NLM, Gene Ontology, GO, and Unified Medical Language System, UMLS. Other sources of terminology include HL7 tables and the United States Health Information Knowledge Base, USHIK, funded and directed by the Agency for Healthcare Research and Quality, AHRQ, with management support in partnership with the Centers for Medicare and Medicaid Services. This concludes Lecture A of Basic Health Data Standards. Semantic interoperability is still unattainable. Even now, the U.S. government and others are looking for ways around this problem. Can we succeed with partial semantic interoperability, or is interoperability a binary function? If the word we don't understand causes an unnecessary death, then we must go all the way.